Right, so we're going to talk about topic 3.3, which is over finding the derivative of inverse functions. So I just want to talk about some notation real quick. So when you guys see this first notation, that means the derivative of f. All right, and then this second notation means the inverse of f. And then this third notation means the derivative of the inverse of f. And that is what we're going to be finding today, the derivative of the inverse of f. All right, now some things that you need to remember about inverses is that if we know that f of 2 is 3, then we know that f inverse of 3 is 2, because an inverse function will take the 3 and turn it back into a 2. All right, so you guys did the activity about the exploration about inverses. So hopefully you figured out that the inverse is going to be the reciprocal of the original. So anyway, theorem 5.9, and that's just how our book labels it, it's not officially 5.9. But anyway, this is to let f be a function that is differentiable on an interval I. If f has inverse f inverse of x, then f inverse of x is differentiable at any x for which f prime f inverse equals x is not 0. And to find that inverse, we use this rule. So f inverse prime to the derivative of the inverse of f is equal to 1 over f prime of f inverse of x, as long as that denominator is not equal to 1. Okay, so this is a lengthy process. So we're given a function f of x, and we're asked to find f inverse prime of 9. So the first thing we want to do is just go ahead and find f prime of x, and we're going to use it later. At the beginning, we don't need it, but we're going to go ahead and find it. F prime of x is just the power rule, is 3x squared. Okay, the second thing we're going to do is figure out when f of x equals 9, whatever number is here. So we're going to find when f of x equals 9. And to do that, we'll just set it equal to 9 and solve it. So sometimes this is a little more complicated. In this case, it's not too bad. Okay, so what that means is that f of 2 is 9, because when x is 2, the function is equal to 9. So what that tells us about the inverse is that f inverse of 9 is 2. We are going to need that later. That's why we're finding it. All right, so now we're ready to use the formula. Okay, so I am just going to take the formula, and in the place of x, we're going to put 9, because that's what we're looking for. Okay, we'll start going through the problem. So the first thing I need to find is f inverse of 9, and that's what we just found right here. F inverse of 9 is 2. All right, then we need to find f prime of 2. So that's why we found the derivative of f. So I'll just take that 2, put it in for my x. So that's going to give us 1 over 12. That's f prime of 9. No, that's f prime of f inverse of 9. Okay. Now just one other thing, like what you can take away from this and from the activity you guys did before is that we know, we're looking at f of x, we know the point 2, 9 is on there. Because when I put in 2, you get 9. Alright, and then for f inverse of x, I know the point 9, 2 is on there. Alright, so that means that f prime of 2 and f inverse prime of 9 are reciprocals. Alright, so if I did f prime of 2, I'm going to get 12. And then I just found f inverse prime of 9, and I got 1/12. So that checks out. Okay, so that one was filled out for you. I just wanted you to watch. This one, we'll do the whole thing together. So the first step is to go ahead and find the derivative of f. Alright, then we are going to figure out when our function is equal to 5. This one is going to be more challenging. So I would put everything on one side, but I don't know how to factor that at all. So I would just start trying numbers if you can't use the calculator. So we want to know when this is going to equal to 0, what x value makes it equal to 0, and then I just noticed that if x was 1, it'd be 1 plus 5 minus 6, and that would be 0, so x is 1. So what that means is that f of 1 is 5, and f inverse of 5 is 1. Very important things right there. All right, so we're ready to use the formula. So f inverse prime of 5 is equal to 1 over f prime of f inverse of 5. All right, we already know that f inverse of 5 is 1. All right, and then I can take that 1 and plug it in up here and find f prime of 1. All right, that is going to be 1/8. That's your answer you're looking for. All right, and then one more time, just to keep this reciprocal thing in your head. So I know looking at f of x that I have the point 1, 5. F prime of x, I have the point, no, not f prime, sorry, f inverse of x, I have the point 5, 1. So that means that f prime of 1 and f inverse prime of 5 are reciprocals. Okay, so if I put 1 in here, I do get 8. And then I already did the whole problem for f inverse prime of 5, and I got 1/8. That all checks out. Okay, now sometimes you'll be given information in a different way. Sometimes you'll be given it in a table, or you'll be given it just different pieces of it, like on example 2. So we know that f is an increasing function, and we know that f of 0 is 3. And we also know f prime of x. And we want to find f inverse prime of 3. All right, so let's talk about this. So if f of 0 is 3, f inverse of 3 is 0. That's important. We need that for sure. All right, I'm going to go ahead and do my formula. Okay, so I know f inverse of 3 is 0, so I'll fill that in. All right, and then if I want to do f prime of 0, I come over here. All right, cosine of 0 is 1, so this is going to be 7, so this is 1 over 7. All right, also, don't forget that f prime of 0 and f inverse prime of 3 are reciprocals. So as soon as we know this is 7, we should know this is 1/7. All right, for example 3, we have another increasing function. We know that f of 10 is 5. We know f prime of 10 is 8. And we need to know which of the following statements is true. So as soon as I see f of 10 is 5, I would say f inverse of 5 is 10. All right, so we would do f inverse prime of 5 equals 1 over f prime of f inverse of 5. All right, and then just go through it all. I know f inverse of 5 is 10. And then I know f prime of 10 is 8. So f inverse prime of 5 is 1/8. Hopefully that's an answer, yes. Okay. All right, so we're going to write an equation for the line tangent to the graph of g inverse at x equals 1. All right, so this is written in a little bit of a different way. So before, we would be told, like, we want to find a certain thing. And so it's just a little different. So what we need to know is find when g of x is equal to 1, just like we were doing at the beginning. So g of x is equal to 1 when x is equal to 2. So g of 2 equals 1. G inverse of 1 equals 2. That is your point of tangency. All right, then we have to find the slope of tangency. The slope of tangency comes from the derivative of g inverse. All right, so that's g prime of g inverse of 1. Okay, I know g inverse of 1 is 2. And then I know g prime of 2 is -6. That's your slope of the tangent line. All right, so we have y minus 2 times -1/6 x minus 1. That one, to me, is kind of confusing the way it's worded, but that is it. All right, your assignment is to complete the topic 3.3 worksheet.